Okay, well, we're doing one-dimensional motion, and rolling this ball back and forth will show one-dimensional motion because it is only going back and forth, not up in the air or anything else. Okay, throwing this ball exhibits two-dimensional motion because it is moving vertically as well as horizontally.
Okay, pulling paper from under a table shows Newton's first law because an object at rest stays at rest. Newton's second law is the change in velocity with which an object moves that is directly proportional to the magnitude of the force applied to the object and inversely proportional to the mass of an object.
Alright, this is basically saying that when I push these two weights, this is 5 pounds and this is 2 pounds, with the same force, the 2-pound weight will move faster due to Newton's second law.
Newton's third law states every action has an equal and opposite reaction.
This basically means when I throw this cart thing, it's gonna move me backwards on this skateboard. Maybe not a lot, but let's see. Alright, this is free fall and air resistance. Dropping this piece of paper off the building will show air resistance. The air resistance is pushing up on the paper while the gravity is pulling down on it, causing its descent to be slower.
When an object moves, it automatically has kinetic energy. So for me walking, I have kinetic energy.
Alright, this exhibits gravitational potential energy because mass, gravity, and height are all acting on the object, but it is not moving. This is elastic potential energy, and it is when the rubber band is stretched, the energy is brought about by the deformation of the rubber band. This pendulum exhibits mechanical energy because both kinetic and potential energy are acting on the object at this time.
Dragging the beanbag chair shows work.
Abbey is transferring her energy to the beanbag chair in order to move it, and this expresses work.
By pulling the skateboard up the driveway and releasing it, we're exhibiting the work kinetic energy theorem.
As you can see, there are 3 forces while going up, which is the mass, the normal force, and the external force, which is Abbey pulling it. Then going down, one external force is disappearing, and she's not pulling it anymore. Alright, this is the impulse momentum theorem, and it's exhibited by me dropping this egg onto this beanbag chair.
An unbalanced force applied for a period of time, which is impulse, will cause a change in the object's momentum and take it to 0. This is elastic collision because the two balls will collide and then bounce off of each other.
Yeah.
While spinning in a circle with the ball on a string, I will show circular motion.
This is circular motion because the object is directed along the tangent to the object's circular path. The string is the reason for all of this. Alright, we're doing centrifugal force, and it's going to be shown by me swinging this around in a circle.
Because of the force acting on the water, it will make the water stay in the bucket as she's exhibiting in a circle. Being able to turn on and off the stove is a torque.
This is a torque because Abbey's hand is applying a force causing this object to rotate around an axis. The 6 simple machines are... Okay.
This is a pulley.
Okay. This exhibits a lever. We are going to use this as a wedge.
There we go. This is an incline plane.
This is a wheel and axle. This is a screw. This shows
elastic collision because the two balls will collide and then bounce off of each other. Oh!
Alright, this string standing still exhibits... Oh, forgot. B!
Pulling a piece of paper from under a table that's not moving shows Newton's first law because, okay, pulling a piece of paper from under a table that's not moving shows Newton's first law because, okay, pulling a piece of paper from under a table that's not moving shows Newton. Why does this always happen? This is a pulley. This is a pulley. Newton's second law is the change in velocity or acceleration with which an object moves is directly proportional to the magnitude of the force applied to the object and inversely proportional to the mass of the object.
This basically means that this 2-pound weight is going to go faster than this 5-pound weight by pushing them at the same force because,